All right. Hey, how's it going again? Thanks for jumping on. Again, just testing this out, getting back into the swing of streaming. Just only hooked up to the YouTube channel right now. We'll be expanding this to LinkedIn too eventually. But I really just wanted to get back and into the sharing and coding live and really just walking through my thought process. So we're back with part 2. On Tuesday, we looked at the different possibilities for a serverless data store. Today we're going to dive into the top 3 that we found and walk through their docs. So we're still not even at the coding stage yet, and I think that's really important to call out, is that far too many people, when they're jumping on a project, just jump right onto the keyboard and start pounding out some code to kind of form their ideas, which is okay as long as you're willing to throw that work away and start fresh once you have a better idea of what you want to do. At this point, I know what I want to do, so let's figure out the right services to get the thing going. Again, I'm working on this project to pull in information from the community, store it, and then basically, write it a couple times a day, and then read it once into reports that I can consume and share it with you. So it's not a high volume activity by any stretch of the imagination. Very, very simple, very, very straightforward. Let me jump over right now to the Firefox view. I'll show you what we're looking at. This is basically our data structure, just to remind myself. I've got parent objects and child objects. Those don't change that often. They come up every once in a while, and there'll be a new one added, but really low change rate on those. But the news underneath each of those child objects is going to change quite frequently. We're going to see that often, and we're going to see new things pop up. We are going to have to change those deltas or keep that delta going. And again, it's I would like to be able to query back and say, show me all the changes over time and graph that. I'd like to be able to see the contrast between different child objects under the same parent. I'd like to be able to compare a few other things. Let me just adjust some of that light there. There we go. Get a little bit more in there. So that's the data structure. Now we came down to 3 potential options. So let me just drop this in the chat just to let you know. If you have any questions, away. Always good to let people know who are joining the stream a little bit later. So pretty straightforward here, right? We've got Amazon DynamoDB, very popular, very common serverless database on the back end. And again, the reason why I'm looking for serverless database is this is a side project. I want to set it up. I rarely want to touch it. I want as low operational burden as possible, and I only want to spend a couple bucks a month on it because it's really just pulling a bunch of information to save me time, so that I can then look at sort of the aggregate reports on this. So we had Amazon DynamoDB. We've got Azure Cosmos DB. Been in the news a couple times lately, not for good reasons, but it's still a phenomenal data service. And then finally, we have Google Cloud's Firestore. Now, I've got a deep knowledge of the AWS cloud, and I've worked with Dynamo a bunch of times. I played around with Cosmos and have investigated Firestore in the past, but for the purposes of this stream, I'm really gonna put on my newbie hat and go through and kind of walk through my thought process of picking the right service, because that's absolutely critical in that I need to make sure that I've got the right service for this project. Because if I pick the wrong data store, I'm going to put too much overhead on myself for work that I need to do regularly. And I don't want to do that. I want to make sure that once this is up and running, that I don't really have to think about it. I just get the results and I can use the results as I see fit. So with that, what we're going to do is we're going to start here with Firestore. I'm just on the default page. Just looking at the size in the stream, that looks pretty good. So if you can't read that clearly, just let me know and I'll bump it up, but I think we're pretty cool. So when here, we already looked at this and we looked at the pricing. The pricing was the #1 metric we used to determine whether or not this was actually going to be a good fit for our project. And the reason being is that that pricing really quickly tells you what's important to the service, whether you have to spin up stuff or not. I'm going to jump there real quick to show you. I don't like that scroll, especially on a stream. That's really bad, but that's how all the Google Cloud pages work. But you can see here, Firestore charges us based on stored data, makes sense, document writes, reads, and deletes, as well as the bandwidth. So we're not paying for instances, we're not paying for clusters, we're not paying for things other than storing data and then accessing that data. That's perfect. That's exactly what we want in a serverless data store. So back up to the top, and you can see here the 3 key benefits. If we scroll up actually a little bit higher, we've got the key points off of it, but the benefits, launch faster, sure, effortlessly scale, fine. What our next step is, so my first tip was what we covered in the last stream, which was read the pricing, and the pricing will help you determine if this service is the same concept that you're looking for, if this is the same kind of idea. The next thing is actually look at the docs. The docs are what you live and die by. They need to be comprehensive, they need to be approachable, they need to be clear. If they are not, then you're gonna have problems. Okay, and this is one thing that I really like to get into as far as this gives me a feel for what's it like to write to the service, what's it like to read data out. Querying is going to be key. I'd rather do less work to write in to get the data in the way I want. I don't want to have to backflip to like smush the data into a format that makes sense. I like as simple as possible. I'd like some JSON documents. I'd like to be able to query across those. That would be ideal. I can also do it in a key value store with the Dynamo approach, which is basically just a broken down JSON document anyway. So that's what I'm looking for is how is it going to be for me to connect to this database, to write to it? How's it going to be to connect and query? So right off the bat, we have a quick start, always a good sign, using a mobile web or web client library, using a server client library. So this is set up a database, add data, read it using iOS, Android, or the web client libraries. I think I want this server one because I'm just making a little tool that's going to be a CLI tool for me that I run. And I think that better qualifies under Google's definition of a server client, because here it's set up the same data store, add the data, read data using C#, Go, Java, Note, blah, 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 right? Okay, so that's what I want. I'm going to click on learn more here and we're going to dive in. Now, I actually really like the Google documentation. I think it's pretty clear. Let me just bump that up a little bit. I think it's pretty clear. So it gives you the standard before you begin. Create a new account if you don't already have an account. Also lets you know if you're a new customer, you're going to get 300 credits, $300 in credits, which is nice. And here you're going to start a new project and you can click right in and start a new project. We're not going to go through this tutorial today. I just want to read the documentation to get a feel for it. That's what's going to keep this stream quick. And again, if you have any questions, let me know. But that's pretty straightforward. Now you need to create a Firestore in native mode database. Don't know what that is. But what I believe is this implies another mode that's available that we don't care about. So pretty clear though, click native mode and you can go into the Firestore viewer right here. You can click on the location, so the region in which you want your database. Very simple, straightforward so far. Now we need to set up authentication. Okay, you can click through the console or here's the command line. So in this case, you're creating a service account, you're adding a policy to it, and you're adding keys to access that database. Logically makes sense. You need to create the database, then you need to grant some permissions onto that database. I do like the Google Cloud approach here where you've got a service account that is creating, or you create a service account, you're granting just the permissions. Let's see if we scroll over here, how much more? Roles, owners to the IAM. Yeah, so you're just granting owner rights to that project that we just made. So you've scoped this down. This is a service account that only has access to the sample project we're making. And then you're creating a set of keys that can access this project that has the Firestore. Very simple, very straightforward, then tells you how to export that. I like that. I think it's the basics up front. Now, this may be frustrating for people because you're like, I just want to get to the thing, but this is how you get there. So very clear, very straightforward. This is also genius. Languages across the top, in line. What do you want to see? How do you want to see the difference between them? I like to do a lot of stuff in Python. This is adding the server library, very simple and easy. Just upgrading the Google Cloud module on Python to include Firestore. It's an interesting thing with the way the SDK works for Google Cloud. Not all the stuff is available in Python on day one. You have to actually initialize each of it. And does the same thing go for like C#? No, so for C# it works traditionally, it's all there. Go, I think, is the same thing. Yeah, Go is the same thing. It's really just Python that you actually have to pull down the extra services, which is different. You may not be expecting it. Takes 2 seconds, no big deal. And then here we are. We're into the actual meat of the tutorial now that we've got a database set up. We've got a project created with credentials to access that project and then specific keys to access things within the project. Now, and we created a Firestore table. Now we're actually into the meat. Database, Firestore client, give it the project ID. It should automatically, based on how we set up earlier, pull the Google Cloud credentials in. And then how do we do the data? So adding data, very simple. We declare a collection and declare a document, and then we add in keys and values. Oh crap, that's super straightforward. Okay, in an asynchronous, and there's a way to do it with a wait. So if I had a big chunk of data and didn't want to wait for the transaction back and forth, I could do it asynchronously, but really simple. Connect to the database, shove your data into it. I like that. It's very much in line with how I want to do things. If you're adding a second one, you still have the same collection, and you just add a new document. Now I assume, because I didn't read, because I'm walking through this, that parameter is a key of some sort. So let me just see stored document. So Firestore stores data in documents which are stored in collections. Creates collections of documents implicitly. The first time you add data to the document, you do not need to implicitly create collections or documents, or explicitly create documents. Good. So yeah, I assume the A Lovelace and A Turing are actually keys that you create, and then that will reference your document. So you need some sort of keying structure. Makes sense. Let's see real quick how we read stuff here. Reading, you get a reference to the collection, and then you can stream it. Okay. Use the get method to retrieve the entire collection. That is very, very cool. We're going to jump away from the modeling, away from getting the data. We're going to just see what it looks like for perform simple queries. Again, love this all the way across. Here's all the different ways to query this, even more, everything all in one. Again, to keep it simple for Python, we're defining an object to store the data that we're pulling out. It's a little overkill for a lot of things. You don't necessarily need all this, but it's a good practice to put it into an actual object. In this case, we're doing a collection. Oh, it's actually setting all of it. Okay, that's making a database collection. And then here, all we're doing is we have a city collection, and then you're saying where key state is equal to this value. Simple. Where the capital is equal to true. So in this case, it's everything, something that's set. So once that query is in place, you then execute the query and stream the results back. All right, super simple. Love it. Great. This is exactly what I'm looking for in a database. It is document based, so I just shove a bunch of JSON at it. This is great. Don't have any challenges here. The only question I would have is, are there limits on this? So while we're here, let's go Google Firestore document limit. See if that comes up with something. 1 meg limit makes sense, right? So at least that's according to a Medium article. On this case, stored data is a gig, blah, 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 collection on ID. So here's all the constraints that you need to. This totally makes sense. Yeah, 1 megabyte for a document. So basically what that means is I can just shove key values at it until I hit a meg, and then I need to go to a next document. Love it. Great, so far. That's very much in line with what I was looking for. Again, if you have any questions, let me know, hit me up in the chat here and I will answer them. So let's go to Cosmos. Cosmos DB is Microsoft's fully managed NoSQL. Again, we looked at pricing, and this thing prices based on the way we want. It's based on data in, query, data stored, and how you're reading and writing it. Let's go to the docs. Don't like this. It's across. Docs should be front and center. Docs are the way I understand your service, to see if this is a good fit, to see if this is a good architectural decision for me. In this case, I don't want to go right to community support. I want to see your damn documents. I liked the fact that, you know, with Google, it was right in your face. Like, here's a quick start. We will get you up and running and walk you through this, which was great. Though this isn't bad. Develop an app with Mongo, Table, Gremlin, Cassandra. Oh, that's because the Cosmos is a weird service in a good way. It supports a bunch of different ways of looking at your data. I hope they're all serverless. But in this case, we can do query our data and then choose between serverless and provision output. So this is not a great quick start approach to me. I'd like to see something that's a little more straightforward. But let's open a new tab and look at the developing an app using Core SQL. So it tells us right off the bat that, okay, we're going to need this SDK. And this tutorial, let me bump this up to make it easier. So this tutorial is going to create, creating, connecting to the Cosmos account, configuring a project in Visual Studio. Don't want to do that. If you ever use Visual Studio on the Mac, it sucks. 2019 is horrible. 2022 looks like a good one, but 2019 is just dog slow. I'm on an M1 Mac Mini maxed out, and this thing rocks. It flies and everything. I replaced a Core i9 with it, but Visual Studio is just brutally slow. I can't even say the word, otherwise I'll get censored here. But okay, ignoring creating a project in Visual Studio, creating a database in a container, adding items to the container. So they're using the word container like Google was for collection. I don't like container because that for me is like a Docker container, but I guess that's what they call it within the service. Again, naming is important, just like docs are. So create an account, okay, subscription name, resource group name, account name, API. Dear Lord, that's a lot of information. So right off the bat, look at how much effort is required to actually make a Cosmos DB data store. Enter the basic settings. So enter the basic settings for a new Cosmos account. Subscription name, resource group, account name, API, what kind of API? So Cosmos 5 APIs, core, MongoDB for document data, Gremlin for graph data, Azure table standard. So I love the fact that you can do graph data. I think graph data stores are completely underutilized. That isn't this use case. I have other use cases that I would love to come back to this for. But right now, this is, I'm already too much. Like here's a screenshot of making it as, no. Let's jump ahead a little bit and see if this is actually going to make sense. Go to .NET, list the two. So we're looking at MVC core for a web app. Keep going down. Okay, create the account. Same all that info again. Looking at geo redundancy, multi-rights. Yeah. This is a ton of stuff to get up and running. Remember, Google was like 4 things and clearly delineated as to do X, do Y, do Z. You're good. Copy the keys, and then they want you to create. Now that I won't bang them on the ASP.NET Core web app stuff. That's super overkill for most things. I just want a simple command line, but they're not going to have a command line example because very few people are going to hit this with a command line. But if we look at this, they're creating views. Forgive my scrolling, please. I just want to get to the code. But again, this is a lot to figure out. Okay, there is a build a console. Sorry, let's jump into the console. Same thing. We're going to scroll down past all that stuff because it was the exact same thing. In this case, we're setting up a connect here. This is what we want. So creating a program, great. Give it the endpoint URL, give it the key to connect. We're creating a Cosmos client database and a container. Once that's in place, simple, just a one-line connect. This is the one-line connect. Great, that makes sense. Starting a new program, getting the async, good. Okay, we need to create a database. Sure, it's also asynchronous. That's why the await commands. So create it, get the Cosmos client, and then finally, do we actually write some stuff? So get the demo, get the async. Yeah, I mean, this is fine. This is all standard .NET code. We're finally now at halfway down the page creating a container, which is a collection in Firestore. And then once that is, we can finally add items. They, again, create a full class because, it's C#, you got to class everything. And then they are putting it there with it. So they try to read an item, which is typical, big .NET code, okay. And then they create a family object. So again, this is a lot more than I wanted. Part of that is .NET, just the way that C# works in .NET is a lot of heavy lifting. But they don't have other options. I got Java or Node.js or .NET. Where's Go? Where's Ruby? Where's Python? Where are the other language examples? This is not what I want to see. I assume I can use those languages to connect to this stuff. It's a cloud service. Why wouldn't I be able to? But right away, I'm going to eliminate this for our project, for this project. Love to circle back onto Cosmos for a graph-based database because I think that is the easiest way to get into graphs because like Amazon Neptune is not serverless yet, hopefully. So for that one, this would be a great fit. Graph databases are good for relational items with weight of relationships between them, but we're going to eliminate Cosmos. Cosmos, you're done. You're out. Get here. Documents not good enough. Documentation insufficient to get me moving. Okay, back to the big one. This is, everybody understands DynamoDB, or at least this is one of the most popular services out there. It's been around for a long time. Huge thing. I'm going to click on getting started. So here's courses, and then scroll down and I get tutorials. So I can get a video, I can get the service primer, hands-on, query and manage DynamoDB tables by using Python. That seems what I want. Let me click on that. Overview, tutorial, DynamoDB table, you can use Python, Boto 3, the AWS SDK for Python, that's Boto 3, for interacting. Okay, So why this matters, you should understand, I love this, you should understand how to model your data to fit both your application's data access and your database's underlying model. When architecting a new application, you want to know that your database choice can handle the increased load from additional usage of your application. This is exactly what we're doing. We're walking through the service choices, we narrowed them down to 3, now we're looking through the docs to make sure it lines up with what we want. More advertising. I love the side here. This is an intermediate level tutorial. It's going to take me 2 hours to finish. Tutorial will cost me less than $2, assuming I do it within the 2 hours. That's solid. Technologies used. I need an account. I'm going to be creating Cloud9, which is their online SDK. So this is solid. So application background, data in and out. Let's go to the application background. We're going to scroll through this real quick. I'm not going to walk through this tutorial. Create an account, open up an IDE, download the supporting code. The supporting code literally downloads a tar from S3 to give a deep dive, and there you go. So nice, easy. Inserting and retrieving data. So here, love it, terminology. Here's what a table is. It's a collection of data records. An item is a single record. Attributes are a data element, and the primary key is the unique identifier for that item. Okay, that makes sense. Data modeling, perfect. You can throw this and it gives you an example using books. Here's how you would do it. And then it gives you, here's how you create a table. So you can run this code, create table, in the editor. And okay, so they're just jumping past the creating because this tutorial was about querying the data and getting stuff out. So here's an example of putting stuff into insert the item. So this runs, it makes a connection to DynamoDB. It pulls up the table, and then it's using a batch writer as batch. So it's queuing all these operations to send them through as one. Put item. Item is author type. So it's just literally shoving through, just like in Firestore, as far as the straightforward here, just take a chunk of keys and values. Really simple. How do I retrieve? So get item, I can pull it right by key. Okay, that makes sense. So I'm getting this key and author, this will give me an item. Okay, now can I query? Let's look at the query before we make a decision here. Retrieve multiple items with a query. Like it? Again, just run this code in your IDE. That's pretty straightforward and simple, but we want to see the actual code. So in this case, we're running query, key conditions, expression is a key equals John Grisham. And then it returns items. Okay. So I find this is a little bit clunkier than what we were looking at with Firestore. If we flip back to Firestore, Firestore had where, capital and true. So it has sort of this tuple construction, but both are really straightforward. And again, remember, this is a tutorial for Dynamo. This isn't even the hands-on. So if I just jump backwards a little bit, or not the hands-on, but the, here, let me actually go to the documentation. I think it's under resources. Yeah, developer guide. And then it's everything here, how to set up Dynamo, how to access it from the AWS CLI, using the API. Again, this is what I want. This is what Google has, this is what AWS has. I don't know why Microsoft doesn't have this yet. Java, JavaScript, .NET, Node, PHP, Python, Ruby, C++, Go, Android, iOS, right? Examples in all of them. So if I click on Python, here it takes me to the SDK, and then I can look at the SDK documentation. So this is solid. It tells me, how to program with Dynamo, the programmatic interfaces. Now this is all like lower level conceptual stuff. That's really important to understand how this works under the covers. I love the tutorial, sort of the quick start structure, the how-to guide here in Google Cloud. I'm going to give Google Cloud the win here. I think this documentation makes it way easier to understand what is going on. I got crystal clear on 3 lines of code to query, or to query and then do something with the results. If I go back up to adding a document, it's a one-liner. So is Dynamo, but I think the query structure is a little bit better for Firestore. So I'm going to try Firestore for this project. I think that seems to be the best bet. Let me jump back here to this. There we go. I think this is the best bet based on what I'm seeing in the documentation. And that for me is a really important filter. So we started with pricing. We started Googling across all the different options looking for serverless data store. And then once we found a couple options, we dove in deeper and we looked at the different pricing models to figure out, was it actually serverless or is it just kind of, coasting on that serverless name and saying like, oh yeah, no, we're serverless, but you're going to pay for instances and clusters and you're just not going to manage them. Don't want that. Literally just want to pay for the data I store and for my reading and writing to each of them. So that's cool. That's in place. Next thing that I want to make sure here was this stream, we dove into the documentation. Show me what it looks like to create a data collection or store or whatever it is, or table, and then to put items in and then to read specific items out and to query things. Azure dropped the ball on that. There was just way too much overhead to create something in Cosmos, and then way too much overhead in the tutorials, not enough language choices. AWS, not bad, had that nice tutorial that exactly hit what we wanted. I think we got lucky there. The documentation overall, solid as well, explaining the basics of the service so that once you had that, if you are already familiar with a specific language or framework, you could use those concepts and read the API documentation and understand what you're doing. But I think Google did the best job of holding your hand and working through it and saying, look, this is it. Here's the code. You don't like this language? Click, on the tab at the top of the box, and you get the language of your choice. And of course, every language under the sun is represented here. That's really good. I think that's absolutely required for builders. If you're wondering why I'm harping on architectural choices and it's taken me 2 half-hour streams to figure out what exactly I want to do, is because this is one of the most critical decisions for any project, is making sure you're using the right service. And you're probably thinking, wait a minute, aren't you a security guy? Aren't you the cloud security guy? Yeah. Architectural choices and making sure you're using the right service have an absolutely massive impact on your usage and on your overall security posture. If you are not using the right services, if you are bending over backwards to make something work that really shouldn't be working in your use case, you're going to have security problems because you're going to open up things. You're going to open up things further than they need to be. You're going to be using a service in a way it wasn't intended, and that always leads to problems. So it's really important to do this ahead of time. I was also applying principles of the well-architected framework. All 3 cloud providers support it and have that concept: AWS, Microsoft, as well as Google. I do a course on the AWS one over on Cloud Guru. You can check that out on my website, markn.ca. But the important thing about the well-architected framework is you're actually applying 5 pillars. You're looking at cost, performance, reliability, security, as well as operational burden. We're looking at cost. We were looking at operational burden. I'm not super concerned about performance. Reliability, I'm assuming there's a huge amount of reliability in these databases, especially for the level of stuff that I'm using. And again, low reliability requirements, low performance requirements for this particular project. So I'm focusing on that cost, focusing on that operational burden, and that has led us to Google's Firestore. So that's it for today. Let me know at MarkNCA, hit me up with any questions. I'm going to be continuing to go through this process to build this project out. I find it helpful to actually speak out my thought process. Hopefully you do too. We'll see you in the next one.